Hello all, I am Dr. Pravas. In today's class, we'll discuss about peephole optimization. So what is the meaning of peephole optimization? Remember one thing, peephole optimization is nothing but it is also called as what? Machine dependent code optimization. Code optimization. Okay. So peephole optimization is nothing but it is called as what? Machine dependent code optimization method. So the first one is called as redundant load or store instruction. The first peephole optimization is what? Redundant load or store instruction. So what is the meaning? Just say move A to R0. Move A to R0. Move A to R0 means what? Generally there are suppose two registers A. Suppose I have two registers, one register is A and R0. Move A to R0 means we'll move this A value in R0, or we can assign right like this, R0 equals to A. Means here we just assign A value in R0. This is called as what? Move A comma R0. Okay. So similarly, move R0A. Move R0A means we can write what? A equals to R0. That means we'll assign R0 value in A. We just assign what? R0 value in A. This is called as what? Load or store instruction. Load or store instruction. But remember one thing, move from what? A value in R0. Again we'll write move from R0 to A. Means we store, just say we store A value in R0 and again we store R0 value in A. What is the meaning? Both are redundant instruction. So we can eliminate any one. I am eliminating the second one. Just eliminate any one of the load or store instruction. Okay, remember one thing, we can also write like this. This move A, just see, move A comma R0. We can also write like this. Someone has written like this, what? Load what? R0 comma A. Then someone has write like this, what? Store R0 comma A. That means what? We'll assign what? R0 equals to A. That means also R0 equals to A. That means also R0 equals to A. Here move means what? We'll move A value in R0 or we'll assign A value in R0. Just say we just assign A value in R0. We can also write like, but both meanings are all meanings are same. We can also write like this, what? Load R0 comma A means we'll assign A value in R0. Just say A value in R0. Or similarly, we can also write like this, store A in R0 means A value in R0. Okay, but all meanings are same. Okay, we can also use move, we can also use load, we can also use store. Okay, but in case of move, just say in case of move always moves from left to right, but in case of load and store always moves from what? Right to left. It follow right to left, but move means what? Left to right. This is important, remember, but all meanings are same. Okay, this is called as redundant load or store instruction. If both are same, we can eliminate any one. Next one is second one, jumps on jump. Jumps. What is the meaning? Just try to understand. We just assign, this is my first level, go to L1. In level 1, we just assign what? Go to L2. In level 2, we just assign go to L3. In level 3, we assign what? T1 equals to A plus B. Just say when we'll go to level 1, it will go to again this one. When we'll go to L1, it will jump to here. When we'll go to L2, it will jump to here. So directly we can also write what? L equals to go to L1 and L3, and L3 equals to what? T1 equals to A plus B. We can write simply, means we can eliminate these two levels, L1 and L2, because no need to write. We can directly assign here L1, L3 instead of L1. This is called as what? Jumps on jumps. Okay, so this is my optimized code. This is my optimized code. Okay, now we'll see the third Peephole optimization, machine idioms. Machine idioms. This is one of my increment operator, I equals to I plus 1. I equals to what? I plus 1. We just assign, just say. We can also write like this, I equals to I plus 1. What? Move this I value. Move this I value in R0. Then R this 1 value in R0. Because we have already, just say this I. Suppose R0 is a register. So we will assign what? Move I in R0. Then we'll add one value in R0, because R0 already contains which value? I value. We just add I plus 1. I plus 1. Or we can say my I value equals to 5. I value equals to 5. We'll move I value in R0, means 5. Okay. Then we'll add 1 in R0. So now my R0 contains which value? 5 plus 1 equals to 6. After adding, then we'll move what? We'll move what? R0 value in I, means this I plus 1 value in this. So this R0 value in I register. I register means 6. We'll assign this R0 value in I. Okay. So this is the assembly code. This is called as assembly code. Assembly code for I equals to I plus 1. Okay. So some compiler just consider this assembly code, and some compiler also consider simply write what? INCI. Some compiler also consider, means consider what? INCI code instead of writing what? I equals to I plus 1. Means for the increment operator, some compiler also consider directly write like this INCI, and some compiler also consider what? INCRI. Okay, means for increment operator. So these are called as the Peephole optimization or code optimization method. Okay, so in the next class we'll discuss about liveness analysis. Liveness analysis. This is very important topic. This is very important topic. Means for how to means minimum register allocate for the means 3 address code. This is very important topic. In the next class we'll discuss. Okay, thanks for watching.